Hello everyone, my name is Mane and today I will be explaining tachometer.
So what exactly is tachometer? So this device is used to measure the rotation speed of a shaft or a disc as in motor or other machines. Let us study about the front panel of the tachometer. This is on and off switch. This is on, this is off. This button is called as memory button. It is used to store the highest value of speed of motor or engine so that they can be used further for calibration and threshold. This is measuring button. For doing measurement, we have to hold and press this button and then we have to rotate the shaft. This is rotating shaft, which is the main element. This shaft is attached to the engine or other machines. As the shaft rotates, the magnet moves near the coil of the wire, generating an electric current. The amount of current generated is proportional to the speed of the shaft. Let us understand the working principle and the block diagram of tachometer. Tachometer employs a rotating disc with a marked pattern that interacts with the sensor, generating pulses proportional to the rotational speed. So let us go deep into the block diagram of tachometer and let us understand how all the components work as a unit. The magnetic sensor detects the rotation of the wheel or disc attached to the rotating object. The signal conditioning circuit amplifies and filters the signal from magnetic sensor. The microprocessor calculates the rotational speed from the processed signals. Then the display is used to present the measured rotational speed in RPM. There is a section called as memory which is used to store the RPM values for further use. The advantage of using tachometer are accuracy. Contact tachometers are generally more accurate than non-contact tachometers. This is because they are able to make direct contact with the object whose rotational speed is to be measured. Versatility. Contact tachometers can be used to measure the rotational speed of a wide variety of objects. Durability. Contact tachometers are typically more durable than non-contact tachometers. So the disadvantage of using tachometers are they require contact. Contact tachometers require physical contact with the object being measured, which can be inconvenience or impractical in some cases. For example, it may not be possible to safely stop a rotating object in order to measure its rotational speed with a contact tachometer. It can damage the object being measured. Contact tachometer can damage the object being measured, especially if the object is delicate or has a soft surface. Can be limited in speed range. Some contact tachometers have a limited speed range, which can make them unsuitable for measuring the rotational speed of high-speed objects. We will see application, use, and types of tachometer in the further video.
So there are two types of tachometer. One is with contact and another is without contact, and they have various applications. They are used to calculate the RPM of the motor so that motors can be used properly with proper functioning. They are used to calculate the speed of engine so that the engines are run efficiently without the problem of overheating. They are used to calculate the rotation of the propeller so that no problem is caused during the aviation of the aeroplane.
So let us go one step further and let us understand how we use tachometer to calculate the speed of shunt motor. So this is the overall shunt motor setup that we used.
So this is setup of DC shunt motor, and we are going to calculate the speed of DC shunt motor using this tachometer. So what we're gonna do is insert this shaft into the shaft of the motor, and we are going to press this button. So let's do it. So the speed which is showing is around 380. It's fluctuating, so we can consider it as 380.
We are going to carry out more such 3 readings. In those 3 readings, we will going to vary the resistance, which will cause a variation in voltage, and hence we will note the deviation in the speed of the motor.
Earlier it was about 380, now it is showing 450, and hence the speed which is showing in rotation per minute has increased. So let us calculate the speed once. Let's see it is increased or not. So it's around 490. It's touching to 500. So yeah, the speed is increased. So let us see that the speed has affected or not. So the earlier speed was around 450. Now it is showing 509, which is around 500. So we can consider it as 500. So yeah, with increasing resistance, the rotation per minute of this motor has increased.
So after tachometer, let us see the working principle and block diagram of Luxmeter. So Luxmeter uses a sensor called as photodiode, which is a semiconductor that converts light to electrical current. The sensor conducts electrical current directly proportional to the amount of light it measures and give digital output. So study of components in block diagram. The photodiode converts the ambient light intensity into an electrical current. The transimpedance amplifier converts the photodiode's current output into a voltage signal and amplifies it to a measurable level. The low pass filter removes high frequency noise from the amplified signal. The analog to digital converter converts the analog voltage signal into a digital signal. The microprocessor calculates the illuminance in lux from the digital signal and controls the display. The display presents the measured illuminance value in lux or foot candles. So the advantage of using a lux meter are objective measurement of light intensity. Luxmeter provides an objective and quantitative measure of light intensity, allowing for consistent and accurate assessment of lighting condition. Versatility. Luxmeter can be used in a wide range of applications. Ease of use. They require minimal setup and operation. Portability. Many Luxmeters are compact and portable, making them convenient for use in various locations. Another advantage is wide measurement range. They have a wide measurement range, enabling them to assess light levels from dim to bright environments. There also exist some disadvantages of using a lux meter. So the first one is limited scope. Lux meter only measures visible light intensity and they cannot measure other forms of radiation such as ultraviolet or infrared light. Sensitive to external factors. Lux meter readings can be affected by factors such as angle of incident of light, the presence of reflective surfaces, and the presence of filter or lenses. Another disadvantage is the cost. Lux meter can range in price from inexpensive consumers model to more expensive professional models, and the cost may not be justified for the application. Calibration requirements. Lux meter may need to calibrate it periodically to ensure accuracy.
So let's have a look at digital light meter / lux meter. This device, with the help of photosensor, converts luminance into electrical signals and hence can be the best device to calculate the luminance and use it in ample of applications. So let's go deep into the front panel of this device. So this is the front panel of lux meter. This is photosensor / photodiode, which is used to convert the luminance into electrical signals. These are units of the lux meter, which is lux and foot candles. Basically, one lux is equal to 1 by 10.6 foot candles. So this is these two knobs are for changing the range, which is around 0 lux to 50,000 lux and 0 FC to 5,000 FC. And this button is for data hold. So if we are calculating the data, and we have to hold it, then we have to switch this button. And this is used to convert digital signal into analog signal, and we can get the analog output also.
So that's all about the lux meter. We will see the application part in the further video. The application of lux meter are photography and cinematography. Lux meter are used to ensure that the light conditions are adequate for photography and cinematography. Industrial settings. Lux meter are used to monitor the lighting conditions in industrial settings to ensure that they meet safety and productive requirements. Home automation. Lux meter can be used in home automation system to adjust the lighting levels automatically based on the ambient light intensity.
So let us see how exactly this lux meter works. So I will take 3 readings at 3 different locations and we will notice the deviation in the readings. So first of all, I will hold it near my body. So the reading should be around 0. Yeah, so it's coming out to be minus 005, which is around 0. So I will, in second condition, I will hold it near the tube light. So let us see. The reading is coming out to be 418, which is obviously greater than the previous one. So let us go to the third location, which is in sunlight. So here we are to take the reading in sunlight. So let's do it. Okay, so the reading is coming out to be 1788, which is obviously greater than the previous two readings. So it can be clearly seen where there is more light, the readings are greater in number, so the lux is more.
So let us now have a look at the thermal camera. The FLIR E6 is a compact thermal imaging camera that is designed for a variety of applications, including electrical, mechanical, and building inspection. It has a 160 into 120 infrared sensor that can detect temperature differences as small as 0.05 degrees Celsius. The E6 also has a built-in digital camera that can be used to take visible light images. Let us have a look at the working principle and the block diagram of this camera. The main components of the FLIR E6 are infrared sensor. This is the heart of the camera and is responsible for detecting infrared radiation. The E6's infrared sensor is a 160 into 120 focal plane array that is made of microbolometers. Microbolometers are small, sensitive resistors that change resistance when exposed to infrared radiation. Optics. The optics of the FLIR E6 are responsible for focusing the infrared radiation onto the infrared sensor. The E6 has a fixed focal lens that is designed to produce a sharp image at a distance of 1 meter. Electronics. The electronics of the FLIR E6 are responsible for processing the electrical signal from the infrared sensor and converting it into an image. The E6's electronics also control the camera's functions such as image zoom, temperature measurement, and image recording. The FLIR E6 has a built-in digital camera that can be used to take visible light images. The digital camera has a resolution of 640 into 480 pixels. The images from the digital camera can be overlaid with the thermal image to provide a more complete picture of the scene. Here are some of the applications of the FLIR E6. Electrical inspection. The FLIR E6 can be used to identify electrical problems such as loose connections, overloaded circuits, and faulty components. Building inspection. The FLIR E6 can be used to identify building problems such as air leaks, insulation defects, and moisture intrusion. Environmental monitoring. The FLIR E6 can be used to monitor environmental conditions such as air quality, water pollution, and soil contamination. Home inspection. The FLIR E6 can be used by home inspectors to identify potential problems with homes such as energy loss, water damage, and mold growth. Automotive inspection. The FLIR E6 can be used by automotive technicians to identify problems with engines, transmissions, and electrical systems. Let us now have a look at the advantages and disadvantages of this camera. Advantages: temperature measurement. Thermal cameras allow for non-contact temperature measurement. This is useful in various applications. Visibility in low light. Thermal imaging works well in complete darkness or low light conditions because it detects infrared radiation rather than relying on visible light. Versatility. Thermal cameras can be used in a wide range of applications, including building inspections and even search and rescue operations. Disadvantages: cost. Thermal imaging cameras, including the FLIR E6, can be relatively expensive compared to traditional cameras. Limited detail. Thermal images typically lack the level of detail provided by visible light images. Environmental conditions. Some environmental conditions, such as heavy rain or thick fog, can affect the performance of thermal cameras. Let us now have a look at the front panel. So these are the various picture settings that we have in this camera. The measurement tab is used to check the hot spots and the cold spots in our view of the camera. These are the various color modes that the camera has: iron, rainbow, gray, below alarm, and above alarm. The temperature scale is used, auto and manual, to detect the temperature range. The settings tab include measurement parameters, save options, and device settings. By clicking on this button here, we can view the gallery, where all the images clicked are stored. Let us now click a few pictures.